All right, thanks everyone. Thanks for coming. Welcome to September 2022. Big month. What's been happening with the new iPhone and the Apple event? We'll get started tonight with a little bit of a summary of the month that was, and then we're going to a talk by Christian. So to begin with, I'd like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of the land, and pay my respects to elders, both past, present, and emerging. A little bit of housekeeping as always. Hey, I'm Zach. I help run CocoaHeads along with Christian, who I think is in the other room. But if you see either of us around, feel free to say hey or let us know if you have any questions or concerns. As always, a massive thank you to Billu for sponsoring the event. They provide the great space that we're in tonight and also help pay for our costs. So thanks to Billu. And a reminder that we have a code of conduct as CocoaHeads. You can read it in full on the website, but it boils down to 3 key points, and they are: be respectful, be inclusive, and be aware. If there's any questions or concerns about that, please see myself or Christian. We also have a Slack community. Feel free to join there. It's a good place to hang out throughout the month and also to ask questions or hang out tonight if you're watching from home. And yeah, feel free to take a screenshot of that slide if you're watching from home and join that Slack. So welcome to anyone who's attending for the first time. We have anyone tonight? I think everyone's welcome. Round of applause. But watching at home, one person attending for the first time. Welcome. always good to see new faces. And a bit of a shout out to other groups that you might like if you like what you see here tonight. We've got Melbourne CocoaHeads. They run their event on the second Thursday of the month, and they also do a great job with live streaming it. So that's available on YouTube, just like we are tonight. And a shout out to Canberra CocoaHeads as well. I don't believe they live stream, but they've started up again over the last few months. So looking ahead to what's happening in October, our event will be on Thursday, the 20th of October. We'll be back here, the Billu offices. And we've got a special talk lined up from IBM, so that will be very exciting. And actually, I forgot to put out the gear, but I've mentioned this the last few months. We've got a bit of a charity auction going on. So got some old Apple gear to essentially give away in exchange for a donation to a charity. So what we have left is the binder, some pins, and the t-shirt, which is in the top right there. If you're interested in any of those items, just come and see me. I've got them in a bag over there, and in exchange for a small donation, it can be yours. For those in the room, that t-shirt, it does have an Apple logo on it, but it's being covered by a Zoom thing at the moment. So just quickly on tonight's schedule, housekeeping, which is what's happening right now. We've got a month in review, and then we've got Christian's talk on Swift on the server, which I'm very much looking forward to. So what's been happening? It's been quite a month. There was an Apple event, and there was also a lot of app updates. So a little bit of an update from people in the community who've released cool things. We've got Focused Work, which released a new major update, and I've got a little video to show you for that one. We'll watch that now. So really nice work there from Michael, the developer, adopting a lot of the latest iOS features. And then the other sort of community built app that I wanted to call out was Aaron Stevenson's sticker drop app. Launched on the App Store, it was yesterday, maybe the day before. And it's a pretty cool idea. It takes the new photos feature in iOS 16. We can drag the main subject out of an image and turns it into like an iMessage sticker pack, so you can easily use it to respond to messages. It's actually doing quite well. This video that he put on Twitter took off, and I checked before the event, and it was number 5 in the US App Store, which is the biggest app store, is my understanding. And so it's a pretty solid effort from Aaron. And for those of you who remember, he presented in May, or he helped run the May accessibility event. So he's very passionate about what he does, and he's developed a pretty cool project there. So yeah, kudos to him. So what's been happening? Got all the new software updates. iOS 16 and watchOS 9 are out. iPadOS 16 is coming later, presumably alongside iOS 16.1 for the iPhone. And the Live Activities API is in the Xcode 14.1 beta, but it's not sort of public just yet. The first beta of that came out this morning. So if you're developing any live activities for the new phones, you can do that with that version of Xcode. So what happened to the Apple event? Well, there was a new Series 8 Apple Watch, as well as a new rugged Ultra Apple Watch, sort of targeted towards extreme sports like diving, hiking. It's got cool features such as better GPS, and it's more durable. The Apple Watch Series 8, on the other hand, is a bit more of a minor update. The main feature being wrist temperature sensor for aiding with women's health in particular, so around menstrual fertility cycles. And sort of the other headlining feature for both watches are the crash detection, which, similar to fall detection, Apple are sort of expecting will help save lives and be pretty cool. It's got the AirPods Pro. It's a second generation with an H2 chip. You've got improved noise cancellation and volume adjustment on the buds itself, which I know for many people who have the first generation, it's always been a bit of a sore point that you can't adjust the volume without sort of an Apple Watch or your iPhone. We've got the iPhone 14 and iPhone 14 Plus. Honestly, relatively small update, little things like improved photography and videography. They do get a similar crash detection feature to the Apple Watch, which I think is pretty cool, as well as probably their coolest feature, the emergency SOS, which allows people in the US and Canada, US and Canadian customers to send emergency messages via satellite, so without the need for mobile reception. Apparently it works worldwide, but will only be available to US and Canadian customers at launch. The more exciting of the iPhone updates, the iPhone 14 Pro and the Pro Max. So a lot of the goodies of the iPhone 14, as well as better camera system, obviously having that third camera and a bit of a thicker camera system on the back there. But I think the main thing to call out is the dynamic island as a replacement for the notch. So it's a pretty cool use of the space up there, and there's new APIs to allow you to interface with that and sort of put your own apps you out there. So we've got a little animation that wants to play. It does not.
Shoot after a few seconds.
Oh, okay.
Almost like interactions.
That's not dynamic.
Hey, it's not dynamic. Okay, so that doesn't want to play. But anyway, I had a cool little animation of it dropping down and showing your face like this. Anyway, that'll be available in an API to develop with that will be available sort of later this year, which is pretty cool. Oh, this is just frozen completely. So I am many slides ahead. That's nice.
Excellent. That's not playing.
Excellent.
Yes. Ventura?
No, it's just totally.
No, it's a feature.
Okay.
Bloody Apple.
Yeah. Sorry, 1 minute.
I like how
We took this. Yeah, it's just totally busted. So.
Oh, Inception.
Can you see Saul?
Is it postcode?
It's just loading. Oh, yeah. Cool. Let's try that animation one more time. Break it again. Hey, that worked. All right, cool. So that's a little summary of the Apple event. And now I'll hand over to Christian for his talk on putting Swift on the server. Everyone give him a round of applause.
Well, thank you very much, Zach. And also a round of applause for Zach and the team behind CocoaHeads Sydney. It's amazing to see some good here. I should say I'm now also an organizer, so thank you for that.
Wow. Pat on the back.
Yeah, okay. Excellent. So I have the pleasure to give my half-prepared talk today, so don't expect loads. But I'm going to be talking about server-side Swift today, and it's an adventure that I've only recently gone on myself, again, thanks to Zach, because as always, he provides great tutorials that I can just copy paste and then everything works. Yeah, and basically, I have been able to set up my own Swift server to handle some of the requests and the backend things that I need for my own app. And that's been a really fun experience. I'm going to share that with you. So usually on these events, we talk about how to develop apps for iPhone or whatever device that it is. But today we're going to have a look at what goes on behind the screen of it all. No, that's not quite what I meant. The server, of course. Yeah. So just a hands up and participation in the live chat. How many of you have developed or thought about developing your own backend in Swift or not? Good handful of hands, 2 handfuls maybe. I think it's a really, really fun learning experience. It's many of us probably are thinking about becoming full stack developers, expanding into other technologies. And it's a really, really cool learning experience. And doing it in a language you're already pretty familiar with is going to help a lot. So, and it certainly did for me. A lot of the apps that we build start out just being on a single device, usually the iPhone or something like that. And same goes for Android. So, but as users grow, we get more users, it gets more and more features. We might also want to bring the app to more devices or bring in new capabilities that's requested from users, which is really great. So eventually, or even from the beginning, you probably want to transition into more of a client-server application and be able to fetch data from a backend or offload some heavy work or synchronize data between devices. And we always need a backend for that. It's an umbrella term for many things, but a backend nonetheless. If you're building a to-do app or a camera app, a game even, you might not ever need to have an internet connection for it to do everything you need. That's perfectly fine. Not everything has to be the same. However, if you're building something like a weather app, or in my case, a stocks app, then you won't get very far without having to fetch data from somewhere. It's going to see a lot of the same weather, and they're already not very precise. So, okay. Yeah, eventually we're going to fetch some server from somewhere. So I am personally building an app called Stocky, which is an investment portfolio tracking app where you can add some portfolios, follow some stocks, put in your transactions, see your returns, all kinds of things like that. And one of the most basic features, obviously, is to fetch the current price of whatever stock you're following or fund or whatnot. And I get my data from a third-party provider. But currently, that comes with a couple of downsides for me. So first of all, the data that they provide is not always structured in a way that really fits into my use case. And I see that quite often. And it's also really a challenge when you develop a backend, because how, obviously you want to ask your users or consumers, but how do you build something that fits what people want? It's a challenge. And secondly, I have a lot of reference data that I need to fetch, and I don't want to do that for every single user or every time the app launches or something like that. Got to stay up to date. So I'd rather sort of offload that to a layer in the middle and don't use all my API credits on things that change very rarely. And it's been a thought that I've had for a couple of years, I guess, since I started this project, where I just thought about setting up like a proxy or a cache server or something that just sort of gathers all the information and then provides it in a way that makes sense to my use case. And now I've finally done it. So it's been really fun. I am by no means a backend guru. So I also needed something that was really easy and simple to start with. And luckily, Swift is becoming more and more widespread for server-side development. And it's a really great opportunity for an indie developer as myself, at least in my free time, where you want to build something that's useful, but you don't have a lot of resources, you don't have a lot of money, probably doing most of the things yourself. And I'm happy tonight to show you how you can build your own server applications using Swift. But there's also a question, why would we want to use Swift on the server, because we already have so many other languages that's more or less built for that purpose. And quite often server components are built using entirely different technologies, tools than the app itself, and it requires more work, requires more people to do it. So being able to use Swift for building your server-side things also, it can help bridge this technology gap, and we can have a very similar environment across the entire tech stack. And on the Swift website, they say themselves, the goal of the Swift project is to create the best available language for users ranging from systems programming to mobile and desktop, scaling up to cloud services. So it's pretty clear that Swift was created with the intent that it should be a language for all platforms. And it does make a lot of sense because it's a really popular and powerful language. It's really nice to work with, and it has very few limits. It's a language that we already know very well, and which makes it just easier to get up and running. It becomes easier for the teams to read the code, review the code, see if there's any problems. Swift is relatively new, and it's kind of built by taking the best bits of all the other languages. And so it doesn't have a lot of like legacy, it doesn't have a lot of tech there, but it kind of got a good foundation to build upon. And using Swift for our entire stack allows much more reusable code, because you don't have to convert between the one type or the other. You can take your code and plug and play it into something else, and you're good to go. And as I mentioned, if you already use Swift, it's super easy to get started with it. So, and if you need to convince the people in suits, Swift also uses less resources, meaning we need fewer servers, ideally. Because of that, it means we can process requests and things much faster, again, meaning fewer servers are needed. Swift is really built with safety in mind, so I would make the hypothesis that it is safer and it's less prone for anything to go wrong. At least it's easier to figure out what went wrong, because a string is actually a string. And using the same language for everything, again, mean you might need to hire a lot less people. And that might be a strength, that might be a disadvantage, excuse me, but I think it's a really good opportunity. And in addition to all this, recently we've seen this study that shows that, or confirms that Swift is really quite efficient. And by using Swift on your servers as well, maybe you're doing something good for the planet as well. And that's pretty hip at the moment. So why not consider that as well? At this point, we've all been convinced that Swift is the very best option out there. So let's go build a server app. And in this talk, we're going to have a look at Vapor. How many have looked at Vapor before? Good handful again. Yeah. It's one of a number of frameworks for Swift that allows you to create web applications and usually export it via some sort of REST API. And from there, you can do pretty much anything you want, like any other Swift program, because you've got the whole language to your disposal. You can do anything you want and react to anything you want. And Vapor is built in Swift, and it runs great on Mac and Linux and Windows, which makes it really excellent to deploy on a server and access via the internet from your app. And at the core, at least in the case of Vapor, a server application is really just a Swift package. So if you've done that, you already know how to do it. What you want to do is to go to your Xcode and create a new package. And you can either create this separately, or you can do it as inside your existing app project to get started. It makes it a bit easier. And the package defines an executable target, which maps to the application entry point as we know it. And really all you need to do to make the application into a web application is that you add Vapor, the framework, as a dependency. And once that's all done, all we need to do is initialize the application, set up some what they call routes, and we're good to go. And when you do that, your package.swift file as you get from your new package might look something like this, or it should at least have this in it. So what you'll see is that we have added Vapor as a dependency to our package. And we've got that executable target, in this case, my Stocky server. And you'll see the product Vapor is also dependency of that, which means when we run the server, we've got Vapor available to us. And that's really all we need here. So to show a really simple starting point, I built a little my Stocky server. So what you've got here is you've got the main function as you have in any package. And that's where that's the initial entry point. So that's where we create a new application. We set up in this case, a get route and a post route. And that corresponds to receiving like a get request to the greet endpoint or a post request to the echo endpoint. And those would then be responsible for handing that request down to a method by the use parameter, argument, whatever camp you're in, which goes down to these greet and echo functions. And you can either return just some data, or you can handle a post request, get some data out of it, go down to your database, return some data, whatever you want. This is really all you need to get started. And we might already run this server now, and you're able to call these endpoints. For example, localhost/greet, it'll say hello from Stocky server. That's it. What we really want to do though is to be able to call it from probably an iOS app. And in our app, we might create a server client, which then handles the interaction with our server through, in this case, some async methods. And we would use URL session to make an asynchronous request to the server, pass the response, just as you used to. In this example, we are just expecting a string. So it's really easy to deal with. But of course, I'm guessing most of you have written code like this before. You know, you can work with any codable type, any JSON. It's really, really easy to go from there. It's really just one more line of code to handle a full JSON response. So super, super easy. Yeah, and assuming you are using Swift UI in this example, all you really need to do to be able to fetch that data and refresh your view is that here we've got a view with a little with a text, and we've attached the task to that, which creates a new server client. We call we call the server with on the greet endpoint, and we wait for the result. We get something back. We update the state of this server greeting, and if everything goes well, your view should now show whatever response it got from the server. Or if something went wrong, it should display an error. And that's really how simple it can be to implement a server. Now, this is obviously a really, really simple example. And most likely you'll need something a bit more advanced than this, but don't be fooled, because this simple setup it can be enough for a vast amount of apps that you use already. It's very, very many apps that just you need to fetch some data. For example, a weather app, you just need to fetch some data and you can show it. You really, really don't need a lot of complexity on top of this. Now, let's go into a little bit more detail on what I have done in my project. First of all, we would like to create some models that we need to send to the server, or the data that we expect to get back. And they'll usually be structs conforming to codable. Here I have 3 different kinds of data that my server can return. And we've got a simples response that represents a stock symbol with its name, date, currency, different kinds of things. And we've got 2 responses for an exchange containing the, again, symbol, the name, description, all kinds of things. And we'll need to create these models both in our server and our app as it is right now, because the server needs to know how to send it, the app needs to know how to understand it. So we'll have a bit of duplication there. Next up, we want to configure what our server does, and we'll be configuring some routes. And this is my actual code. I'll take comments afterwards, please. So on my particular server, I don't have a database and I just store the data on disk because that's really good enough for what I need to do right now. Super easy to expand from there. But it's a start and I can call my server, get my data when I need it. It's really, really easy. So I've configured 2 routes here. And this is for my version 1 of the API. So you'll see on the left that you can build your path using as many sort of strings as you need. It's just, this gives me like a URL/v1/exchanges or /symbols, whatever you want. You can keep going as long as you want to add more, what are they called? Components. Sure, let's go with that. Yeah, and in this particular API, I just want to fetch an array of stock exchanges or symbols, and that's really all I need it for. And these 2 endpoints then point to 2 respective methods that you'll see on the right on my Stocky server, which fetches the requested data from my storage and returns it to the app in a response object. And that's really all I need to set up my server. These response objects, because I want it to be an array, so I've wrapped it in a struct, for example, for Exchange, because all things you want to return from Vapor needs to be conforming to a content protocol, which is on the very, very basic surface, essentially just codable, but it really tells, like it conforms to all the protocols. So Vapor knows, okay, this is data that I can serialize, go back and forth. That's all we need for this example. So, and because I want to return an array, I've wrapped it in these models that just returns me a nice JSON array. And that's really all you need to make this work. Of course, you can also handle post, put, delete requests. I don't need it for my server, but I just put in an example here. So it's really the exact same thing. You just call the post function with the same parameters instead of the get function, or you can use put or delete. And in the case of posts, obviously, we're going to post some data that the server needs to read. So you can either do it via a body payload, and you'll get to that access by looking into the request body and then pass that as a string, and you can then return, good to meet you, whatever you put in there. Or you can pass it in as a path parameter. You just get it from request parameters get, and then, for example, name, and you can write good to meet you, whatever name you put in. And it's the same for any put or delete request. The only thing that changes is really what you put in those methods. If you want to go down, fetch the database, return something, it all happens inside from there. So now we've got all this up and running. What do we need to do next? Well, we'll run the server. And then that's kind of the easiest part, because you just tap this nice play button and your target will build, it'll run, set up the server, create a little web server on your local machine, and you're ready to call it, to test it out. And probably the easiest way to get started, you can use like curl, postman, or whatever, but I'm just using curl here to show it. You can call the get request just by going to the Vapor standard URL /v1/hello, and it'll return hello CocoaHeads Sydney. Okay, excellent. Or we can pass in, we can make a post request with a parameter v1/me, parameter name Christian. It'll write good to meet you, Christian. The same with just a post with a body. You pass in with the data parameter, and in the bottom we're passing it in as JSON format. Same thing. You just add the JSON header, and it knows how to interpret it. Server handles it, pulls out the name, returns it. It's really, really easy to get started. And obviously for my particular endpoints, it's going to return a bit more data, but I have my v1/exchange endpoint, and it just returns an array of all the exchanges in the whole world, almost, like in Australia. We've got lots of JSON data, and you've seen that before. You can pass it into a codable type. It's really, really easy to get started. So to reiterate, if all that goes well, it's the same as before this one. We go into our app, we can create like a Stocky server client, put in the endpoint, create a function to fetch exchanges, and you can just get what you need from the internet, just like anything else you might download. And that's it. That's really all you need to get started. And I guess I'd like to show a bit more in a demo. I did bring a special guest with me tonight to help me out with that. So, Craig.
Let me show you, but first, let's set the mood.
You touch it down.
Too much?
No.
There are at least 3 Craigs in this room.
Yeah.
Well, I was gonna say,
that video.
raise your hand. 1, 2. There you go.
4 if you
Special guest, Craig one.
Oh.
What's worse, working for Apple, I'm just like, shit, was I supposed to do something? I can creepily look at a laptop if you want. I can do that really creepy look too. It's pretty easy.
pull it off.
Sorry?
You wouldn't pull it off. We'd all start running.
Oh, there you go.
All right, good with some entertainment while I get myself ready. So I think the font should be okay. Let me know. Let's move back. Great. Okay, so this is my actual server code that's running live right now on the server, not here. So again, I've got a package here called Stocky Server. I'm importing my Vapor framework and finance kit that I've created to help me deal with financial data. We've got our main entry point, which is a struct that I just called Stocky Server Bootstrap. And in here, I've got my main method where I will create my server. I will call Bootstrap, which basically just loads all the initial data from disk, sets it up. I'll initialize my Vapor web application. I'll set up my routes as I've showed you. And we'll come back to that bit and I'll run the app or the server. And that's it. So we're ready to accept requests. So let's go ahead and do that. If it's not already running. If not, it is now. So just as I showed in the slides, we can just go ahead and use curl, for example. So first one, we'll try the hello one, and we get a nice response there. And you'll see in the console, Vapor will write out started server, and there was a get request to /v1/hello. So we are connected. And from there, we can really just do, we can do something else. For example, we can do me. And it says, good to meet you, Team Apple. So that was post request. And like before, I've got my exchange endpoint that returns a lot of data, and the same thing for the symbols. Just a get request returns lots of data, about 12 megabytes actually. So you don't want to do that too often. Yeah, and that's really how you call your server. So let me go into a bit more detail on what is going on. As I showed in the slide, in my actual app, I've got this Stocky server client, which just defines a base URL. Right now, it's just pointing to my local machine. We're setting up something with an injected URL session. And then I've got my 2 functions or methods that just calls the URL with a part attached to it, awaits the response, decodes the response, and returns the array of exchanges or symbols in that case. And that's really simple. So in your server, when you build it, it'll probably pay off to think about how you want to handle your storage, how you want to store data, do you want to use a database, how you're going to sort of manage that. And I would definitely recommend to handle that in a separate class. Or even, now that we can, an actor, because servers are by nature asynchronous, and it means many requests will fire often, and they might clash. So the actor keyword, if you don't know it yet, it was part of Swift 5.5, if I think 6. Excellent. It's really just a way to abstract, let the system handle any sort of concurrency problems, like it's gonna basically block the threads while it's processing the things, and it'll make sure to handle all that for you, so you don't need to do it yourself. So that should prevent most sort of race conditions. And so we're doing that. So in my storage, I am just, let's go down. Oh, let's do this first. So in my server, I am bundling it with some default data, because my server will fetch my actual data source and update that on a scheduled basis, and then it will store that on disk. But if it failed to update or hasn't yet, I preloaded with some default data that it's production data, but it might be outdated a bit. And I just have that as a JSON file inside my project, ready to be loaded on launch. And that's what happens. That's what happened. That's about one storage. That is what happens here when we've got this load exchanges that just reads that file and saves that to memory essentially. And we've got the same for simples, super easy. And likewise, when I do refresh the data, I just go in and write that new data to that file. And then the next time we can just read that again. It's really simple. And it works for me at this point. So this is a few couple of functions that's not too important. And coming back to, that'll be that. So coming back to this function or this thing I do when my server doing the main method. So this is I believe it's an API off paper. So basically what I do here is when my server boots or my application starts, I set up an event loop group, basically just like a scheduled timer. And that will, in my configuration here, after 5 seconds, I will refresh all the data on my server, fetch it from the real data source. And then it will repeat that every 720 hours, which would be once a month, roughly. And that's really it. So basically, once I boot my server, it's ready to handle requests. It regularly updates its own data. We're good to go. And that kind of concludes the demo. So we'll jump back here. What do you think, Greg?
But don't you know?
How cool is that?
Very cool indeed. I'll take that. Thank you. So where do we take it next? We've got something really simple up and running. It's technically production ready. Maybe you want to add a few more things to protect it depending on your, how sensitive your data is. In my case, it's fairly public, so it doesn't really matter too much. But right now I do run fully open API, and obviously you should protect that a bit. So where do we take it next? So one thing I have done, but I would like to point out again, it's a really good idea to version your APIs. So that's why I use v1/whatever endpoint I have. You can use it to not necessarily avoid breaking changes, but tell your consumers, in my case myself, but if there are any breaking changes or new things, they can migrate accordingly. It's a very common practice and definitely something you should consider as well. You might as well. Next step would obviously be to deploy this server to the cloud or host it in your home on your Raspberry Pi, whatever you might fancy, make it available to the internet in some way. And you really should configure SSL or some kind of authentication or both to make sure that your server is only approachable by things you want it to be connected to. Obviously, a valid next step would be to implement some sort of database or a little bit more advanced data storage. You might want to handle users, logins, I don't know, but it'll be an obvious next step. It will also be a really good idea to write tests for your server. Now that everything is sort of abstracted, it's and it by using stubs and things, it makes it really simple to test and verify that when you actually call the server with the right requests, it's going to return the right responses. So that's really helpful as well. And last, keep exploring, keep figuring out what you can do. You might learn something new. You might figure out a use case for your app you didn't even thought about because now you've got extra capabilities. You might be able to improve its performance greatly. There's a lot of options. And two of them that I would like to point out, because I know you picked out that I mentioned that I've got duplicated code before, and I'll come back to that now. So one of the things that is a disadvantage when we have an app, we've got lots of models, now we create a server that has the same models, obviously we end up with duplicated code. This is a really good time to take that extra hour or two, create a new package, put all of your common models that both things use in there, and then make that package a dependency of both projects. You get a single place where you've got those models, you can test them separately. It prevents duplications. It's a really, really low hanging fruit to pick next. So you want to do that. And yeah, with just a small refactor, after you've done that, you can change your app and server to use that same model code. It's really simple. A use case that I've thought about, haven't done it yet. I'm not sure if it is a good idea. You can tell me afterwards. In Stocky, I do have a small suite of UI tests that hopefully is growing by the second. And UI tests are run as white box tests, meaning that they don't know anything about your code. They run on your app just as any user would see it. And all they can do is tap buttons and go around. But it makes it really difficult to mock your data. And ideally, you want your test to be consistent. So if you keep hitting the real endpoints, there might, your server might be down, it might return wrong data, your test will fail. And it's going to be really, really slow to do that approach. So the best way is to do some sort of mocking to get some consistent results. And I thought about, well, when you've got a local server running, you can take your UI tests and you can inject like a base URL that you use when you build a project, and you can target your app to use that instead. It will ideally make it much more stable, much faster, and might not make it, it's not the best solution, but it's way better than hitting your production APIs or some sandbox APIs, way faster. Another use case I thought about is that right now I use Fastlane to automatically take screenshots of my apps in various languages, screen sizes, and ideally for the App Store, and ideally they should all be identical, because it's weird if one screenshot has one price and the other one has a different one, or even in the same listing. It just looks weird. So do yourself that favor to make sure that you've got consistent data when you do that. And again, with my local server, when I run these screenshot scripts, it's essentially also a UI test. You can point it there. You might set up that server now to return some mock data instead of real data, but in my case, it's nearly the same. And it just makes sure that every time you run those screenshots or tests, you get the exact same results, no matter how long you run it for. You don't risk that it changes, because if you deal with stock data, it will change many thousands of times during the day. And it's going to look weird if you have different prices and times on your screenshots. So it's an option. You could also use like Proxyman or similar tools, but I thought about it. I'll see if I implement it. It's worth thinking about. We're starting to come to an end. So if you do want to learn more, put a few resources up here. I watched a great video from this year's WBC about this, which was a big inspiration. And also I'd like to point out, Zach wrote a great article on how to actually get up and running and deploy your server app to the cloud, in his case with Linode, or essentially any Unix or Linux server. And that's the same exact article I followed step by step. It's still relevant, it still works. It's really great to get started. And he also covers how to configure SSL, or at least that you should, and some other good points. So that's a really, really good resource, I think. Obviously, there's also lots of resources around the community, books, courses, open source projects, the server-side Swift conference in Copenhagen. if you're interested in this area, there's a lot of things going on. As a bonus, when we're talking server-side Swift, you don't just have the option to use Swift on your backend applications. We have quite a wonderful community, I think, and there are tons of projects that you can build things with. A project that launched in 2017 or 18 maybe is John Sundell's Plot and Publish, which lets you build static websites entirely written in Swift. And that's how I built my own blog and also the Stucky website. Really simple, not a designer, but it's really simple. You give it some static markdown files, it generates all of the HTML, all the CSS, deploys it, super easy and extremely fast. If you're interested in a talk about this, let me know afterwards, we can figure it out. Next, I would like to mention that here at Below, where I work, where we are now, building apps, front-end and back-end is something we do really well. It is what we do. So if you feel like this is really interesting for you or your company, if you'd like to get some more competencies in this area, come talk to us afterwards, me in this case, or Balash, Daniel. We're happy to answer questions or work with you if you want to. And that's it. Thank you so much for listening.
Thank you. Do you have any questions for Christian?
Yeah.
So where do you deploy these days?
Where do I deploy it? Well, as I mentioned, I used Zach's article. So currently I deploy my on Linode. They have a, 1 gigabyte storage we get for $5 a month. I think there's a limit on traffic. It's good enough for me. It's fairly generous. So it's a really good place to start. $5 a month, not too bad. You can host it yourself. You can start there. You can always migrate. Super easy. So that's what I use.
So a couple of years ago, the choice was, for me at least, was Heroku.
Yeah.
What happened with that? Is Linode better now?
I don't know. I considered Heroku, and actually that WWDC talk uses Heroku. I found for my business that their pricing is a bit steeper, and they used to have a free plan or something. Now some weeks ago, they stopped doing that entirely. So you can only pay, and maybe they bumped up the price a bit. Maybe they thought they had something that was too good to be working in the long run. So that's why I haven't used Heroku before. I can't say if it's good or bad or worse or better. I chose Linode. It's working pretty well so far. So yeah.
Yeah, I'm interested. You said backing off that, you actually said something. I was going to ask a question about the migration. How would you migrate to another server then, given the app that you've built at the moment for the client side of it and the server side of it? Because you might have a version 1 out there that's pointing at Linode, and then you're going to have version 2 that would be over on, I don't know, Big Ode or something. Who cares? Whatever it's called.
Yeah, and that's a really tough challenge for everyone that works with backends. How do you migrate your users or clients to a new server, a new version, whatever? Usually it's pretty simple. If like migrating the server, moving a server is fairly easy, depending on your setup. I'm not going to go into enterprise things.
Yeah,
but
it wasn't that part so much.
Yeah.
It was more the client's going to be pointing to something that doesn't exist anymore.
So it's a problem that we've had to solve for the companies I work with, where both for legal reasons and financial reasons, all kinds of things, old endpoints would no longer be available, or had to have increased security, many things. I think a pretty standard approach is to, it's not the best way, but you might have to, and that would be to, let me have a think for a moment. So ideally you want to make it as soft as possible so that your users don't notice. And in previous cases, we've had to do like forced upgrades where we push out a new app update and it says, we do that, and then built into the current app, we've got code that checks the backend and says, whatever minimum version, if I'm below that, we show us full, like some alert saying you must upgrade to use this app. It's probably I'm not going to say it's the worst thing you can do, because sometimes it's necessary, and I don't immediately have other thoughts on how you can circumvent that sometimes. It's not a great user experience. So by all means, avoid that if you can. But yeah, it's to do it in a more soft way. I would probably implement some sort of a feature flag or variable that you again host on a server somewhere. Your app calls it when it launches. Maybe which base URL should I use? You can just flip a switch and then all you users migrate to the new one or a part portion of them. That's kind of what I've approached in the past. So maybe you have some other experiences.
Oh yeah, so one of the things that I've used in the past on lots of client stuff before I even joined Apple was to load a configuration file from a server at some point. But obviously you still have the issue if that configuration file endpoint goes down for any reason, you're a little bit stuck, right? And so there are challenges. I was just interested in your approach and your thoughts.
Yeah, and that's a good like configuration file feature flag. What is kind of the same story, right? So what you might want to do, what I did with my server, is to bundle a default configuration with the app. So in case if that endpoint is down, we've got a baseline we go back to. Maybe it's more limited, but yeah. So that's a very valid approach. Yeah, good question.
When running locally, can you debug it with breakpoints on Maxwell? Does it work?
Yeah. Let's try it. I hope it works.
Famous last word.
Just I
that's what it's one of those things. The moment you go to
it
do a
doesn't
demo,
work, it's Xcode's fault.
yeah, it's always Xcode's.
I'm not. I don't even remember if I tried it, but I believe you can.
Maybe you can.
I believe you can. So
Still running.
we're still running.
Yeah.
That should be good. We've now break there. So let's try to call the hello endpoint once again. Oh,
Nice.
there you go.
Yes, sir. At least you get the credit.
Show Craig's video again.
I had more in my head, but I was. Yeah. Any more questions? Maybe some from the live chat if you.
I'll take some from the room and I'll look.
All good.
Bit of a sidetrack. Oh, sorry.
Oh, correct.
Okay, so once you deploy to a server, cloud server, how do you actually make it start?
Well, my ideal approach would be to hook it up to some sort of Git webhook. So every time I push, it would just pull the new code, restart the service, and then go up and running. With Linode, what I do currently is log in with the SSH, call the do that, what is it said manually. Again, in Zach's article, there's a really cool, he has a utility called supervisor.
Yeah,
That
that's
right?
right.
Yeah.
Yeah.
Which will go in and in case your server reboots or shuts down or something and comes back up, it will go in and automatically bring your server application up again, which can be really useful in cases where maybe they do something unexpected, or it also means that you can just reboot your server and then it's going to come up, it's going to be down in that meantime. But yeah, so that's what I do. It's not the most automated solution right now, but I also don't have to update it very frequently. So it works for now. But yeah.
I was just going to ask if Swift Server can handle WebSockets. There's a way to work with.
I wish I could say, let's try, but I don't know why we're stuck. By Swift Server, do you mean Vapor specifically, or?
Yeah, like if there's a framework or a way to handle WebSockets using Swift.
I don't know, to be honest. I haven't looked into it. I know Apple has several frameworks like, their networking frameworks and all kinds of things that handle WebSockets.
Yeah.
And you've got, as long as it runs on whatever platform you're on, you've got that to your full disposal. I'm sure someone in the room can answer that question for you. I won't try to.
I know, yeah, Apple's got one, Neo, that does it, one of the frameworks underneath.
Which is the basic.
Yeah.
Right,
Yeah.
which is what Vapor's based on, but I don't know of anything else that makes it easier.
Yeah, so
Off the top of my head.
I don't know, to be honest. I'm sure Vapor has that built in some way.
Right, sure.
Sure, but I don't know. So I'll be honest.
There was a question from the chat. What are the cons of Vapor?
Doesn't take 300 meg or anything straight. That's memory.
So the question was, what are the cons of Vapor?
Yeah, what's up?
None that I've found so far.
It's cold enough, it can condense.
Nice. Well done. I'll play that.
Yeah, you don't want Vapor in your server.
Yeah. So another way to ask that question then would be, what's something that you found yourself like almost swearing at the computer when you were trying to get Vapor working? Like that, yeah, right. But that could be like a con, like that's like, what did you find difficult? Like you're like, oh my God, why is this not working? Or was Zach's article so perfect because it was written by Zach that you didn't have that issue?
Well, to be frank, he did send me some sample code that he uses that I base mine on. I'm barely scratching the surface in Vapor, to be frank. So I'm sure there's lots more under the hood. And so again, I'll be honest and say I haven't used it enough to really figure out if there's any really bad things or really problematic things. I haven't found any so far. So it's been a good experience so far. I would say though, looking back at so this presentation uses Vapor 4, which adds support for async await, which probably looking back at some of the older versions that use like futures and promises makes it much simpler to work with. So if I can answer that question retrospectively, if you are on Vapor 3, don't.
I'm laughing because Zach literally said that to me before.
And he said that to me.
I said Christian's code looks a lot nicer than my code in Vapor 3, which is a nightmare, and I still haven't done the migration because some of the database frameworks for like Postgres and stuff have changed, and it's a nightmare. I've got like a half working, no, not even working. It's I've got a branch where I'm slowly doing that, and it's a nightmare. So yeah, Vapor 4 wasn't a thing when I started this server, but I kind of want to start from scratch instead of migrating it. See what happened to that.
Pro tip: go back in time. Tell yourself.
Wait a few months, and
nice.
Yeah, I think it was in a very early beta that I didn't want to touch because I heard professional things, but I probably should have just got beat up first. Anyway.
Oh, good. Well,
Great.
Does it support middleware? Middleware. Does it support middleware?
again, not sure.
I believe it does. Cool.
Thank you very much. Anyway, if there's more questions, come to me after.
Cool. Thank you, Ron. Cool. Well, thanks to Christian for that great talk, and thanks to everyone for attending. That's it for the formal proceedings tonight. Feel free to stick around and have a chat if you like. There's a little bit more pizza, but otherwise we'll catch you next month. Thanks, Zach. Thanks, everyone. Thank you.
He's in Newcastle.